So in this video we're going to look at organic chemistry, and we're specifically going to look at substitution reactions. So our learning intention is explore substitution reactions, including their mechanisms and the chemistry behind them. So let's dive straight in and begin with a definition of what a substitution reaction is. So a substitution reaction is a chemical reaction in which a group of atoms or an atom in a molecule is replaced by another atom or group of atoms. When we look at reactions in organic chemistry, we will often look at something called their mechanism. And the mechanism of a reaction is a step-by-step description of how the overall reaction occurs. In a chemical reaction, there is bond breakage and bond formation. So there is movement of electrons, and these are shown by the use of curly arrows in a mechanism. An example of a substitution reaction is the reaction of alkanes with halogens in the presence of UV light. And this substitution reaction is an example of a chain reaction. So a definition for a chain reaction is a reaction that continues on and on because the product of one step of the reaction is the reactant for another step in the reaction. In this specific substitution reaction, something called free radicals will form, which are an atom or group of atoms with an unpaired electron. And free radicals are formed through a process called homolytic fission, which is where bond breaks in such a way that each atom joined to the bond retains one of the two electrons present in the bond. So the easiest way to understand this type of substitution reaction is to complete one ourselves. So let's look at monochlorination of methane. This process consists of 4 steps, and the first one is called initiation. And as we can see here, in our chlorine molecule, it's broken down into 2 chlorine free radicals, each with an unpaired electron present. And this happens due to the presence of UV light. So this is an example of a photochemical reaction. The second step of our monochlorination of methane is a step called propagation 1. And in propagation 1, a chlorine atom or a free radical that was formed in the initiation step attacks a methane molecule, and this forms hydrogen chloride and a methyl free radical. There is no water present to form hydrochloric acid, and it's important to remember that propagation will always involve the use of a free radical to produce another free radical. So as we can see clearly here, we start with a chlorine free radical and end up with a methyl free radical. The next step is propagation 2, and what we need to remember is that propagation involves the use of a free radical to form another free radical. So we can see that our methyl radical here attacks a chlorine molecule to form chloromethane and a chlorine free radical. So here we can see the methyl attacking the chlorine, forming chloromethane and our chlorine free radical. The chlorine free radical produced in this propagation step can then react with a methane atom as shown in propagation 1, and this is what causes the chain reaction to happen in the monochlorination of methane. So our final step of the monochlorination of methane is the termination step. And in our termination step, a number of reactions occur to stop the chain reaction, and all of these reactions involve free radicals combining together to form molecules. So the chain reaction can go through hundreds of cycles before termination occurs, and the reactions are extremely fast. So the evidence of the termination of the reaction is from any of the 3 reactions that follow here, which is where a chlorine free radical and a chlorine free radical combine to form a chlorine molecule, a chlorine free radical and a methyl free radical combine to form chloromethane, and then a methyl radical and another methyl radical form ethane. Now, evidence for the combining of the free radicals comes from the fact that small amounts of ethane are found among the products in the monochlorination of methane. Also, it's worth noting that if tetramethyl lead is added to the reaction, that there is an increase in the rate. And this is because tetramethyl lead is a provider of free radicals. So what we can say that the monochlorination of methane is a free radical substitution reaction. It is also a chain reaction, and it's important to know that the mechanism is the same if it was for the chlorination of ethane. A final point to note is uses of products of this reaction, and they can be used in flame retardants. So that's it for this video. Have a read over the learning intention to make sure you understand everything we've gone through.